What sense does it make for sharpness to be adjustable on a monitor? Modern monitors often have a sharpness setting, but I don't really understand how it makes sense for such a setting to exist. The software asks the monitor to display a particular pattern of 32-bit RGB values, right? i.e. the OS might ask the monitor every frame to display a particular 1920 x 1080 x 32-bit map. But adjusting sharpness means letting nearby pixel values affect each other, which would seem to imply that the input is no longer being faithfully represented. Meaning it would no longer be displaying what it is asked to display, which doesn't make sense. So I just don't see where this leaves any logical room for sharpness adjustment. Where exactly does the degree of freedom for adjusting sharpness come from?
Per this URL, sharpness on an LCD is part of the post-processing. Even leaving out rescaling/upsampling, for example if you try to display an SD signal on an HD monitor, and the complexities of color calibration, the monitor does not always display the image as given. This is an unfortunate side effect of marketing. Monitor manufacturers like to distinguish their product from other products. From their point of view, if you feed the same signal to their monitor and a cheaper competitor, and it looks identical, this is bad. They want you to prefer their monitor. So there's a bunch of tricks. Usually out of the box the brightness and contrast are wound right up beyond what is sensible. The sharpness is another trick. How do you make your picture look sharper than a competitor that is displaying the picture exactly as sent? Cheat. The sharpness filter is effectively that used in Photoshop and similar programs. It enhances the edges so they catch the eye.
Original question: where exactly does the degree of freedom for adjusting sharpness come from? Sharpness is directly related to the type of signal and content you are viewing. Movies typically look better when sharpness is turned down and the pixels are allowed to blur together a bit. On the other hand, a computer display would want high sharpness for clear text and sharp images. Video games are another example where higher sharpness is better. Low-quality TV signals also can be enhanced with sharpness controls. Being monitors can be used for displaying a computer screen, or movie, or virtually any video source. Sharpness is still a useful setting. This URL. Edit. The op has indicated in comments that this does not answer the question. Op, where in the problem is there room for any adjustment? Like if I tell you x equals 1 and y equals 2, and then say oh, and I want x, y equals 3. That makes no sense. The process of converting the live image/video to electrical analog/digital signals, transmitting over some medium, and recreating that image on a display device is never a one-to-one process. Signal noise, compression loss, manufacturing and equipment variations, cabling/signal type, and other factors come into play. All the adjustments on a monitor are designed to work together to give the end user the highest quality viewing experience, according to the end user. The interpretation is entirely subjective. Op, this answer does not answer the question of why have the viewer adjust the sharpness when this is already defined by the content creator, be it Spielberg or Excel. If we are to follow this logic, then why do monitors need or have any adjustments at all? The answer is that what we see on the screen is not a 100% accurate representation of the original data.
The answer is that a pixel is not what you think it is. There is not a one-to-one correlation between digital pixels and physical pixels due to subpixel rendering. The way colors are displayed is different in each monitor, but most LCD monitors have distinct red, green, and blue elements arranged in a triangle. Some additionally have a white pixel, making a quad of elements per pixel. Thus, not all layouts are created equal. Each particular layout may have a different visual resolution, modulation transfer function limit, MTFL, defined as the highest number of black and white lines that may be simultaneously rendered without visible chromatic aliasing. Monitor drivers allow renderers to correctly adjust their geometry transform matrices in order to correctly compute the values of each color plane, and take the best profit of subpixel rendering with the lowest chromatic aliasing. The sharpness on your monitor reduces the natural blending algorithm used to make lines appear to be contiguous when they are not. Turning the sharpness up will increase chromatic aliasing while producing cleaner lines. Reducing the sharpness will give you better color blending and smooth the lines that fall between the subpixel dot pitch. For more detailed information, see this article, this URL.
You are correct that for a perfect reproduction on the input, the monitor should simply present each pixel as it is delivered. However, your eyes, and your brain, don't see pixels as separate entities, they see a picture formed from pixels. Depending on what it represents, a picture looks better, more attractive, if parameters are intentionally falsified. Sharpness typically increases the contrast at color change edges. For example, a letter in this text is represented by rows of pixels. One line might look simplified 222277772222 where 2 is light gray and 7 is dark gray. Increasing the sharpness increases the brightness fall off at the edge, so the last 2 before the first 7 becomes even lighter, equals 1, and the first 7 after the last 2 becomes even darker, equals 8. Repeat for the other edge, and you get 22218781222. This will look a lot sharper to your eyes. This is done in both dimensions, and a bit more sophisticated, but that should explain you the base idea. Edit, I thought I made that clear in my answer, but the op claims he didn't understand it. Op question, what sense does it make in GT? Answer, it appears sharper to your brain. Many people want that. If you don't care for it, don't use it.
If you want to support the channel, please consider subscribing.